this video, we're going to spend a lot of time using our calculator and solving quadratics multiple ways using the calculator. So the first way is that you try to graph it, and I'll show you that in the calculator in a second. And if your solutions are not integers, if they don't cross the x-axis on really obvious points, then you're going to have to use this app that we have called the PolySim app, and I'll show you that in a second. So let's do number one using our calculator. The first thing we're going to do is click y equals and then type in our quadratic. So we have x squared minus 3x minus 7. And I'm going to try to graph it because what we're looking for is the x-intercepts, where it crosses the x-axis. Now notice that these 2 points aren't exactly on integers. It looks like they're between numbers. So we're going to have to try another method to find these zeros, these x-intercepts. So we go to apps, and we're going to go down to the PolySim app. And yours probably only has a couple of apps in it, but I have to scroll all the way down to get to my PolySim app. So it looks like PLYSMLT2. That's what we're going to. Click enter, and it says press any key, so you can click any button. Now what we want is the poly root finder, because remember roots, x-intercepts, zeros, those all mean the same thing. And I clicked the wrong one, so I got to go back. I can click main if you do that. We want number one, poly root finder. It says order is 2. That's talking about quadratics squared. And it's going to give our answers in real versus imaginary. We click next, which is the graph button. And now we type in the coefficients of our quadratic. So we're going to type in a 1, because that's in front of x squared, a negative 3 in front of the x, and a negative 7 as our constant. And then you click solve, and those are our two solutions. X equals 4.54, and x equals negative 1.54. And that's it. For number 2, the first thing we need to do is actually get it equal to 0. So I'm going to start by adding 9 on both sides. And we get x squared minus 6x plus 9 equals 0. Now we're going to try to graph this. So I used my calculator to graph this, and notice how our quadratic only touches the x-axis at this one spot right here. And that's actually going to be x equals 3. If we look really closely, it's got 1, 2, 3. So right here is our x-intercept, and that's the only one. And this is called a double root when you have only one real solution, but it sort of is hitting it twice, you could say. So that's going to be our double root, x equals 3. Let's try number 3 by graphing, but first, again, we've got to get it equal to 0. So I'm going to subtract 8 on both sides. So we have negative 3x squared minus 8x minus 3 equals 0. And let's go to y equals in our calculator and type in just the left part of this. So this one again has two solutions, but they're not quite on integers. They're going to be at weird sort of numbers, so we need to use our PolySim app, just like we did in number 1, to find those two solutions. And I found them to be x equals negative 2.22 when I round, and x equals negative 0.45. So those are our two solutions to number 3. At the bottom here, it just explains again what is one root or having no x-intercepts. So if you have one root, it's when it's sort of sitting on the x-axis, and that could also look like an upside down version where it just touches the x-axis at one spot. And then example number 2 with these special solutions is no x-intercept, so when it's either hovering above it or it's the upside down and it's below it, but it never actually hits the x-axis, that means you'll have your imaginary solutions like we talked about last class. Topic 7D on using the quadratic formula. One big thing that you need to know about the quadratic formula is that our equations need to be in the form ax squared plus bx plus c equals 0. That's how it has to be before you can actually use the quadratic formula. And you can notice all of these letters from our standard form here are in the quadratic formula, a, b, and c. So the first thing we do, for example 1 here, is figure out what is a, b, and c. So they're just going to be the coefficients. We've got a is going to be that invisible 1, b is negative 4, and c is negative 12. So it's just the number part, just like when we used our calculator, how it's just the numbers in front of your variables. And now we're going to fill out the formula. X equals negative b, and negative b really just means opposite. So it's not always going to be a negative number in front, it's going to be the opposite of whatever b was, because a negative negative would be back to positive. So in this case, it was negative 4, so that means the opposite of that is going to be positive 4. So x equals negative b plus or minus, so that we get our two solutions for the most part, the square root of b squared minus 4ac all over 2a. In this case, again, a is that 1 in front. And now we try to simplify. So following PEMDAS, we're going to do what's in the square root first, and we are going to get 64. All over 2. And now, square root of 64, since that's a perfect square, we really have 4 plus or minus 8 all over 2. And notice how I keep that fraction bar across the whole thing. So the 4 isn't separate, it is also on top of the fraction bar. And then let's simplify, and we're going to get 2 answers here. So really there's the 4 plus 8 over 2 option, and there's the 4 minus 8 over 2 option. So when we go to simplify, we'll get 12 over 2, which is 6, and here we'll get negative 4 over 2, which is negative 2. So these are our 2 answers. It's not always plus or minus the same sort of value. It can be 2 different things, 6 and negative 2. And just to really highlight what's going on, the graph of this should have x-intercepts at negative 2 and at positive 6, just like we got. So we can solve this quadratic in 2 different ways. We can graph it, we can use a quadratic formula. We honestly could have factored this if we really wanted to. It depends on what the problem says to do, but you can always check your answer in multiple ways. Like I would use the polysim map for every single quadratic to make sure that I got everything right. Number 2, I want you to try on your own. So first label your A, B, and C, and then fill out the quadratic formula. So I simplified the inside of my square root, and we get imaginary because we have a negative inside the square root. Now, one thing that I want to talk about is how to simplify using the quadratic formula. So you can only simplify this fraction if all 3 of those pieces have some common factor. So in this case, 6, 2, and 4 can all divide by 2. So this can be simplified if we divide all of those pieces by 2. So this is kind of a really tricky part about the quadratic formula, that all 3 of those things need to simplify by the same number. And right here, we did that, so we're done. And just to show you what this would look like in the calculator for number 2, you would have the graph where it's above the x-axis. It never crosses the x-axis, so that's why we have these imaginary solutions. And then if we tried to use the polysim map, it would literally just say no real roots found. So it wouldn't actually tell you the imaginary ones, but you know that they're imaginary because there are no real ones, and those are mutually exclusive. If it's real, it's not imaginary. If it's imaginary, it's not real. I want you to try numbers 1, 2, and 3 right now, so pause it, do those problems, and come back to them, and I'll show you the answers when we get to it. So our final answer to number 4 here is going to be 2 imaginary solutions, and there are 2 because plus or minus, 2 solutions here. Make sure you realize you're getting 2 solutions. Try number 5. So that first step, hope you didn't forget, is to get everything equal to 0, so we had to add 11 to both sides. So I got 2 real solutions for this middle problem here, number 5, because we got the plus or minus, so that's 2 solutions, and there's no imaginaries, so it is going to be 2 real. So as we set up number 6, pay close attention to the signs, because that is the hardest part about this one, so when we simplify, not messing up those signs. Number 6 has 2 imaginary solutions. We have the I here. The I comes from the fact that we had a negative in the square root, so inside of it is what makes it imaginary. And there's 2 solutions because of the plus or minus. One last thing we're going to talk about is topic 7G, which is the discriminant. The discriminant comes from the inside of the square root of the quadratic formula. So if we look back, the quadratic formula had this b squared minus 4ac part underneath the square root. That is your discriminant. What this does is it tells us how many solutions and what kind we're going to have. So if the discriminant is positive, that means that there is a positive number under the square root. So you would get 2 normal solutions, plus or minus 2 rational numbers, or irrational possibly, but still real. If we had a negative discriminant, that means that you're going to get 2 imaginary solutions, which will never cross the x-axis. So your graph would look either like this or like an upside down, but still never touching the x-axis. If your discriminant is 0, that means that underneath the square root, you had a 0. So when I go to do plus or minus, the square root of 0 is still 0. There's no positive or negative. So it's only going to give you one answer. So that means it's either sitting on the x-axis or upside down, just touching it in that one spot. So to find the discriminant, we are going to just do the inside of the square root part, but we still need to find our a, b, and c. So it's going to be the b squared minus 4ac A, C. Just like before, but only the inside part. Then we simplify this, so we're going to get negative 4 here, and a negative discriminant means that we would get 2 imaginary solutions. Try 8 and 9 and check back in. And just to show you on graphs, problem 7 with 2 imaginary solutions never touches the x-axis. Problem 8 with 2 real has 2 x-intercepts that we can see. And problem 9 with 1 real solution will only ever cross 1 time.